Good morning, dear students. In the last video, we have already discussed about the graphical representation of fringe, how the dark and bright bands are created, and what is linear fringe with beta, and what is angular fringe with theta, and the mathematical expression and conclusion of Young's double-slit experiment. These are all the things that we have discussed in the last video. Okay. So now in wave optics, we are going to discuss about the sustained interference. We have already discussed that what is interference. Sustained interference means it should be protective. If the interference should be protective, constructive means what are the conditions? That is what here sustained interference. Here, the position of maxima and minima of light intensity, that is constructive interference and destructive interference, two things that we can consider out here. The position of maxima and minima of light intensity remains fixed throughout the screen. Remains fixed throughout the screen means you can see one dark band, one bright band like this throughout the screen. You can see the intensity. Whether it is maximum means central bright band will be there. In the edges it will go slightly. Intensity will be minimum. Okay, this is how the fringes are captured on the screen. So the permanent interference. When it comes to interference, the permanent interference. It should be permanent interference. Interference will happen continuously. So continuously, if the interference happens means continuous bands will be created. Okay. So what is the condition for sustained interference? That is what we are going to see next. The first condition is the source should be coherent. Coherent means we have already discussed it, that the phase difference should be 0 or integral multiple of lambda. Okay. So the source should be coherent. That is what the first condition when it comes to sustained interference. Second one, the source should be very close to each other. The source should be very close to each other. I already told you, if you want to try to create dark and bright bands, a small light in front of that, take a white sheet, put a 2-pin hole within 2 millimeter or 3 millimeter gap. And at a certain distance, if you keep another screen, white screen, you can see the dark and bright bands, fringes which is created. And the distance between the two holes should be 2 millimeter or 3 millimeters, so that it should be very close. So the secondary sources S1 and S2, no, there is slit or source that we can consider. Source should be very close to each other. That is what the second condition for sustained interference. And the third condition. Now the third condition is the sources should be point sources. I already said that. Make a hole, slit or hole. Okay, and the slit also very thin slit it should be there. Hole also a small hole will be there. It is not a big hole, because the problem is if the hole or a slit, if it is big, means what will happen on the other side of the paper, the light will started coming over there. You cannot find the fringes. So the sources should be point sources. That is what the third condition is. Fourth one, the amplitude from sources should be equal. Amplitude, we have already discussed it, that it is the maximum displacement from the mean position. This amplitude from sources should be equal. Amplitude equal means the interference should be sustained. Interference will be sustained. That is what the 4 important conditions when it comes to sustained interference. Okay. So this theory part is okay. Up to this, what are the numerics that we can see? That is what we are going to discuss in the discuss next. Okay. So when it comes to numeric Young's double slit experiments, what are the formula that we have seen as a derivation, and keep it remembered, and you can solve this numerics very easily. Okay. Let us go to the numericals. The first problem you can see here. In the Young double slit experiment, the slit are separated by 0.28 millimeter. It is not even 1 centimeter. It is 0.2 millimeter. Okay, and the screen is placed 1.4 meter away. 1.4 meter away, the screen is placed. The distance between the central bright fringe and the fourth bright fringe. Here they have given n number of bright fringes. What is the number of bright fringe that we are taking, that is what they have given. It is the fourth bright band that we are considering here from the central bright band. Okay, the distance between the central bright band and the fourth bright fringes is measured to be 1.2 centimeter. Okay, so determine the wavelength of light used in this experiment. Okay, so here you should consider that this is the central bright band. Okay, n is equal to 0. This is a central bright band, and if from here, if you measure that, if you see that the intensity where it is maximum, there the bright bands will be created. Here the intensity amplitude is maximum, so here the second bright band is created. Second, here the intensity is maximum, so this is this is central bright band, this is the first bright band, this is second bright band, and this is the intensity is maximum third, and here the intensity is maximum fourth bright band. So from here, what is the distance to the center bright band? It is 1.2 centimeter. Okay, so this is what it is given in the numerics, and write the given data. What are the given data? It is given S1 and S2 distance, small d is given. Okay, distance between the two slits, that is separated by d is equal to 0.28 millimeter. Millimeter we can convert into centimeter, meter. Millimeter to meter, that we want to convert it. And again, d means that is the distance that that we can consider from the screen distance. It is 1.4 meter. Okay, from the light source, what is the distance of a screen? It is 1.4 meter. So no need to convert here, it is already in meter. And the x4 is there is the 1.2 into 10 to the power minus 2 meter, it is given. Okay, so fourth bright band value, it is given 1.2 into 10 to the power minus 2 meter. So here the position of fourth bright fringes, that is what we want to calculate. So as per the we have already derived this as a mathematical expression, x to the power n is equal to n lambda capital D by small d. This is what we have already seen. So here we are going to substitute the value which we already know. What is n? N is fourth bright band, so it is 4. And lambda is the thing which we are going to see it here. Wavelength of the light is used only, we are going to find it out. So lambda, we keep it as it is. Capital D value, it is given that it is 1.4 meter. Divided by the small d value, it is given that 0.28 millimeter. We are converting into meter, that is into 10 to the power minus 3. Okay, and x4 value, we are substituting it here. It is 1.2 into 10 to the power minus 2. So we want the value of lambda. So what we have to do, this lambda will goes on the other side. This 1.2 goes on this side. So what will happen? This one lambda will become a reciprocal. So 1 lambda is this value. So lambda means this will become as a reciprocal. So what will happen? 0.28 into 10 to the power minus 3 will go up. And this x to the power 4 value comes as a multiplication into 1.2 into 10 to the power minus 2 divided by 4 into 1.4. Okay, so if we solve this, the value will comes out to be lambda is equal to 600 nanometers. Okay, the wavelength of the light which is used over there is 600 nanometer, that specific wavelength that we can consider. Okay, I hope you understand. We'll go for the next numeric. Next numeric, in Young's double slit experiment using monochromatic light of wavelength lambda. Monochromatic means we have already discussed that the light should not have different wavelengths. It is a single colored light, that is monochromatic. Chrome means color, mono means single color light, that we can consider this here. It is used over here of wavelength lambda. The intensity of light at a point on the screen where the path difference is lambda. We have already seen that the path difference should be integral multiple of lambda, or it should be 0. So there they have given that path difference is lambda, and the unit is given as k units. What is the number of units? Here the unit is considered. Unit means the value is considered as k. So what is the intensity of the light at a point where the path difference is lambda by 3? So at lambda, they have given the value. They are asking the intensity where lambda by 3 is present over there. Path difference is lambda by 3. So this is what we will consider over here. First, we will write here. What is the path difference they have given? It is lambda. Lambda means it is one complete cycle. One complete cycle means 180 plus 180. 180 plus 180 degree. So that is 2 pi that we can consider over there. Already we have seen this in the derivation part. If you want to have a clarification, please refer the previous videos. Okay. So lambda is equal to 2 pi. So what they have given, now we want to find out the value for lambda by 3. So here lambda is equal to 2 pi means this lambda divided by 3. So 2 pi also divided by 3. So this is what the value lambda by 3 is equal to 2 pi by 3. So this is phase difference. Path difference is different. Phase difference is different. Phase difference value is the value which is considered as 2 pi by 3. So path difference, they have given that lambda, that value is 2 pi. So the lambda is different, phase is different. This value equal to 2 pi. So this value equal to 2 pi by 3. So this is considered as the phase. So this value is considered as a 2 pi by 3 value. So from a coherent and incoherent addition of waves, we have already seen A cos omega t. A is the amplitude. Amplitude is 4 times of the intensity. That is what we have already discussed for intensity, how it is increasing for constructive interference. I is equal to 4 into I naught that we have already discussed. So A cos omega t. Omega t means it is the angular value that we can consider out here. So it is pi by 2 is the value. So pi by 2 is the value that we can consider out here. So I is equal to 4 I naught cos squared. This pi value what we have already know that it is 2 pi by 3. We are substituting in this phi. So this is addition of coherent and incoherent waves. We have already seen in constructive and destructive interference. But two waves are overlapping means what will happen, that is we have discussed in that reference we are writing this here. This pi value we are substituting 2 pi by 3 over here. So what will happen, this 2 and 2 will get cancelled. So what is left over? 4 I naught cos squared pi by 3 is equal to I naught. What is I naught here? Intensity of the initial wave. That is the first wave that we can consider, that is I naught. Okay, this we are considering this as I naught. This is equation number 1. So as per the numeric, as per the sum, the path difference is lambda. Okay, so path difference is lambda. So lambda is the phase difference is pi. Lambda value, what is the lambda value, is 2 pi. So phase difference is 2 pi. So what will happen over here? So this value I dash, the second intensity I dash is equal to 4 I naught cos squared 2 pi by 2. So this is 2 pi, okay, by 2 is equal to 4 into I naught. Okay, 4 into I naught that we can consider over here. So I dash is equal to k units as per the diagram. This is I naught is equal to intensity of the initial wave. This is k unit which is given over here. So 4 I naught is the value is equal to I dash. Okay, so 4 I naught is the value. This is I dash. I dash is equal to 4 I naught. That is what I have written over here. 4 I naught is equal to I dash. I dash value we know that it is k unit as per the numeric. So instead of I dash, I am writing this as k. So 4 I naught is equal to k. So I naught is equal to k. This 4 goes as a denominator. So k by 4. I naught is equal to k by 4 is the value that we find it out from the derivation. So this I naught value we are going to substitute in equation number 1. So if we substitute in equation number 1, what will happen? So I is equal to I naught. So I is equal to k by 4. So the phase should be coherent, means there should not be any difference in phase. So that is why it is also coming as a k by 4 value. Okay, I hope you understand this, and we'll go for the next numeric. Okay, next one. In a double slit experiment, Young's double slit experiment, the angular width of fringe is found to be 0.2 degree. That is angular fringe width means theta value. We have previously that we have seen that what is angular fringe width, theta. So this theta value is given as 0.2 degree on a screen placed at 1 meter away. That means D value is given. Light source and the screen, what is the distance? That is capital D, 1 meter away. The wavelength of light is used as 600 nanometer. Wavelength is lambda. Lambda is 600 meter. So what will be the angular fringe width? Angular fringe width of the entire experiment apparatus is immersed in water. If the apparatus is immersed in water, that is what we should consider over here. And they have given a value that the refractive index of water should be 4/3. That is what we should take. Okay. Now we already know that refractive index is 1.33 something. So 4/3 also the same value. They have given it in a different form. So theta value, it is given that it is 0.2, d 1 meter, lambda is equal to 600 nanometer, theta dash, that is the second angular theta. When it is immersed in the water only, we want to find it out. We have already seen that the refractive index's value is given, n is equal to 4/3. We have already seen angular with theta is equal to b/d. This is what the thing that we have discussed in the previous video. So theta is equal to b/d. Now, when it is in water, it is the reciprocal value that we can consider over here. So beta dash is the second angular width. Linear width is equal to 1 by the reciprocal value into beta. Okay, it is 1 by reciprocal into 1 by refractive index of we are comparing with the air, because first the apparatus is in air. What is the refractive index of air? It is 1. Now what is the refractive index? Refractive index of the medium 1 divided by refractive index of the medium 2. Refractive index of the medium 2 is n. N value, it is given that it is 4/3. So this is the second value of beta. So we are considering this as beta dash. So what we have to do this here, theta dash is equal to beta dash by d. Theta is equal to beta by d. Here theta dash is equal to beta dash by t. Second beta value divided by t only, that we are going to consider over here. And beta dash value, we already know that it is 1 by n into beta. So instead of beta dash, we are substituting that 1 by n into beta. If we substitute, what will happen? N will go down and d as it is will be here, and this beta goes on the numerator. Okay, so theta dash is equal to beta by nd is the new angular width of a fringe that we can consider here. So this can be written as 1 by n into beta by d, right? I hope you understand. This can be written as 1 by n into beta by d. Already we know that beta by d value is theta. So what we can write it? 1 by n into beta by d can be written as theta. So 1 by n into theta. So 1 by n. 1 by n means n value is 4/3. 1 by n means it is 3/4. 1 by n means it is the reciprocal of the value which is given over here. 3/4 into theta value, it is already given that it is 0.2. So 3/4 into 0.2. This, if you strike it out, the value will come out to be 0.115 degree. So that is what the refractive index, angular width of a fringe when it is immersed in water, that we should understand. Okay, I hope you understand. And here lots of comparison is happening. So just one by one, you follow it clearly, that you will understand. Okay. Next numeric. In double-slit experiment using the light of wavelength 600 nanometer, lambda is given, right? Wavelength means lambda, it is 600 nanometer. The angular width of a fringe formed on the distant screen is 0.1 degree. Okay, the angular fringe width is given, so that it is considered as 0.1 degree. So what is the spacing between two slits? They are asking small d value, spacing between the two slits. This d value they are asking. So this is theta. We want to convert this into pi into radian value. Radian value we want to convert it. So to convert it into radian, last year we have studied that it is pi by 180. We want to convert it into radian. Okay. So 0.1 into pi by 180. Pi value we already know that it is 3.14 divided by 180. So 0.1 into 3.14 divided by 180 radian. Okay. So degree to radian that we have converted this. Lambda value, it is nanometer. It is given in 600 nanometer. So nanometer we are converting into meter. So 10 to the power minus 9 is nano value. Okay. So a small d value that we already know. What is the formula which connects theta, lambda and d? This we have already discussed in the previous videos. That is, theta is equal to lambda by small d. So now we want the value of d. So d, we will take the d on the other side, theta down. So small d is equal to lambda by theta. Lambda value is already given that 600 into 10 to the power minus 9. And theta value, we have already found it out by radians, that 0.1 into 3.14 divided by 180. So if we solve, simplify this, we will get the value of D is equal to 3.44 into 10 to the power 4 meter. Okay. So these are all the numerics which is related to the topic which we have already discussed this. And what are all the numerics which is present in the book? You try it out. And if you have any doubt, just text me. Okay. Rest of the thing, we'll see it in the next video. Thank you.